Hello all, my name is Penukonda Sairagram. I am studying in computer science and engineering in section B. So subject is high performance computing and the topic I have selected for AAT Tech Talk is classification performance of data mining clustering algorithm for remotely sensed multispectral. So the introduction to remote sensing and multispectral data is the remote sensing involves collecting information about the earth's surface using satellite or aerial sensor technologies. Multispectral image captures data across different spectral bands, providing detailed information about land cover and land use. Accurate classification of multispectral data is essential for application like environmental monitoring, agriculture, and urban planning. So the importance of data mining in remote sensing is the data mining technique help extract meaningful patterns from large multispectral data sets. Clustering algorithms are unsupervised methods that group similar pixels without prior labels. Effective classification improves decision making process in various remote sensing application. So these are the importance of data mining in remote sensing. And then let's move on to the other topic, which is overview of clustering algorithms. Clustering algorithms categorize data points based on their inherent similarities. Common clustering techniques include k-means, fuzzy c-means, and hierarchical clustering. Each algorithm varies in complexity, sensitivity to initial conditions, and ability to handle noise. So this is the overview of clustering algorithm basically. So it tells us what is a clustering algorithm briefly. And then let's see what k-means clustering algorithm is. A k-means partitions data into predefined number of clusters by minimizing within cluster variance. It is widely used due to its simplicity and computational efficiency. However, k-means can be sensitive to initial centroid placement and may converge to local minima. So this is what k-means clustering algorithm is. It's just the partitions data into predefined number of clusters by minimizing within cluster variance. So the k-means can be sensitive to initial centroid placement and may converge to local minima. And then we have fuzzy c-means clustering algorithm. Fuzzy c-means assigns pixels membership degrees to multiple clusters, allowing for ambiguity. This method is useful in multispectral data where boundaries between classes are not distinct. Fuzzy clustering often produces more accurate results in complex land cover scenarios. And then the hierarchical clustering. These are basically all types of clusterings we have to know so that we could get a clear picture of the topic. So the hierarchical clustering builds a tree-like structure which is called dendrogram, which representing nested cluster. So it's in the nested kind of structure. So then it can be algomerative. which is nothing but bottom up or divisive top down. So the tree like structure could be from bottom to up or also from the top to down. This approach is flexible but computationally intensive for large data sets. So this is flexible but computationally intensive for large data sets. So it's a little bit complex to use for large data sets. And then now let's see the performance matrix for clustering evaluation. Common metrics include overall accuracy, purity, and the adjusted rand index. These metrics help compare the effectiveness of different clustering algorithms. Proper evaluation ensures that the selected algorithm provides meaningful and reliable classifications. Challenges in clustering multispectral data. High dimensional data can lead to the curse of dimensionality, affecting clustering accuracy. Noise and outliers in multispectral data can distort cluster boundaries. Choosing the optimal number of clusters remains a critical challenge in unsupervised classification. So, these are the challenges in clustering multispectral data. And then we have comparative performance of clustering algorithms. Studies show k-means performs well with large, well-separated classes. Fuzzy C-means the advantages in mixed or traditional land cover types. Hierarchical clustering offers detailed insights but at higher computational costs. So the comparative performance of clustering algorithm is used to compare the performance of clustering algorithms. So there are many types of clusters here we have discussed before, which one is k means and then c means and then hierarchical. These are the different types of cluster algorithms which we have discussed. So the k means performs with large well separated classes, and the fuzzy c means advantages in mixed and traditional land cover types. Hierarchical cluster offers detailed insights but at high computational costs. So in these three clusters, the hierarchical cluster is more expensive. And then let's see the case study of land cover classification. A case study utilizing multispectral satellite images demonstrated the effectiveness of fuzzy C-means. Results indicated improved accuracy over traditional K-means in heterogeneous landscapes. The study highlighted the importance of algorithm selection based on specific application needs. So these are the case study land cover classifications. The case study utilizing multispectral satellite images demonstrated the effectiveness of fuzzy C-means. And then let's see the advantages of clustering techniques. So the advantages of clustering techniques are hybrid method combines strength of multiple algorithms to improve classification performance. Machine learning approaches such as deep clustering are emerging for multispectral data. These advancements aim to enhance accuracy and computational efficiency in remote sensing. Practical recommendations for remote sensing applications. Pre-processing steps like normalization and noise reduction are crucial before clustering. Selecting the right algorithm depends on data characteristics and analysis goals. Validation with ground truth data is essential to ensure reliable classification results. And then now let's see the future directions in clustering for multispectral data. Integration of spectral and spatial information can lead to more robust clustering. Development of adaptive algorithms that automatically determine optimal parameters is ongoing. Increasing computational power enables the handling of large datasets with more complex models. And then now let's see the conclusion. Clustering algorithms plays a vital role in the classification of remotely sensed multispectral data. Different algorithms have different strengths and limitations depending on the application context. Ongoing research and technologies advancements continue to improve the performance of clustering methods. So the summary of the key points are the choice of the clustering algorithm significantly impacts classification accuracy. Evaluation metrics are critical for assessing performance and guiding algorithm selection, and future evaluations hold promises for more precise and effective multispectral data analysis. So thank you for giving me this wonderful opportunity.